All right, welcome everyone to the CRC Roundtable, a monthly virtual seminar series where we host targeted, inclusive, and informed conversations that match scientific advances and management needs. The webinars are designed for contribution, not consumption, so each seminar invites a diverse range of researchers, managers, and other professionals to have conversations around critical topics. The point of this is to build connectivity between all of us, provide a place to ask the clumsy questions, and to increase our collective competency for decision making. As a reflection of that, the panelists have been given about 25 minutes total to provide the introductory remarks, allowing a full 30 minutes of discussion. The webinars are recorded, so past webinars are available on the CRC website and YouTube channel, and I encourage you to review these, especially if you've missed some of the past discussions. If you could take a minute to type your name, organization, and location in the chat box, we'd love to see where our webinar community is coming from for today. We also ask that you stay muted with your camera off while the speakers are presenting. So we like to start each webinar by asking why this topic, why now, and why these speakers. And this month, we're exploring the connection between two iconic Chesapeake species whose populations are intertwined, Osprey and Menhaden. Fishing pressure, along with environmental changes, are driving down Menhaden populations. Researchers are also seeing lower osprey chick survival rates and signs of food stress. The connection here: Menhaden are osprey's primary food source, and today we're going to explore the current population trends of both osprey and Menhaden, the ecological connections between them, and what's being done to support their recovery. I'm happy to introduce to you our two speakers today. The first is Greg Kearns, a park naturalist with the Maryland National Capital Park and Planning Commission, who will be talking us today about ospreys, and Will Poston, the forage campaign manager with the Chesapeake Bay Foundation, who will be speaking with us about Menhaden. And together, they're going to help us better understand the interconnectedness of these two species and the challenges ahead for their management. So speakers, I'll gracefully let you know if we bump up against the time by turning on my camera or giving you a gentle nudge. And attendees, please feel free to drop your questions into the chat as we go along. We'll try to answer as many of these questions as well as some of the questions that were submitted ahead of time during the discussion time at the end of the webinar. And if we don't get to those questions, we will give the speakers the opportunity to address them after the webinar, sharing those responses and any resources that are mentioned on today's call back with you in a follow-up email. And with that, I'll turn it over to our first speaker, Greg.
All right, thank you very much. Let me get the screen shared here. All right, and let's see. All right, can you see it now? Okay.
Yep, you're good.
All right, thank you. Well, thank you everybody for coming out today to see. Here I'm going to talk about focus on the osprey and its biology today with everybody. I've been working here on the Patuxent River for the past 42 years, and it's really in my blood. And Jug Bay is the name of the park that I've been located at. You can see on this image here, it's Prince George's County, the eastern boundary. It's a 2,000-acre park, and Jug Bay is that wide natural area in the Patuxent River. You can see the entire river there is 115 miles long and empties into the bay down at Solomon's Island and begins up there near Carroll County and Howard and Montgomery intersection. But this is where I've been focusing a lot of my osprey work, actually the lower 45 miles of the river. Jug Bay looks like this. It's the largest freshwater tidal wetland in the state of Maryland. It has over 300 species of birds that occur here throughout the year. Ospreys is one of our real symbols here at the Jug Bay. This is a view from the north looking south and showing you the rich wetlands that provide a tremendous diversity of fish species for the osprey. The osprey, or Pandion haliatus, is means the haliatus is sea eagle. Pandion's a mythical Greek king of Athens, but there's about 1.2 million of them worldwide. The name osprey most likely derived from avis prede, the medieval Latin term for a bird of prey. So ossifrage is another one that possibly it was mistaken for the bearded vulture because they carry bones to break as the osprey carries fish to feed. It's the only bird of prey really in the world that diurnal, I would say for sure, that eats 99.9% fish. During the 70s, ospreys had declined down because of DDT to about 1,400 pairs on the bay, and now there are about 10 to 12,000 pairs estimated on the Chesapeake Bay, and that's the highest concentration known in the world. You can see the range map here. They extend all the way up into Canada, into Alaska. You can see the interior part of the U.S. The yellow is where they're not really found in any large numbers at all, just mainly through migration. In Florida and the Baja California, they're found as year-round residents. But in our area, they are really highly concentrated in the bay because of having the largest estuary in the country. You can see they winter only in South America. Most of my birds go in the northern third of that area. Venezuela, Colombia, northern Brazil, and even into the Amazon. I had one go as far as Bolivia, about 4,400 miles from here. You can see there's 4 subspecies of ospreys throughout the world. There's our North American subspecies. There's a Eurasian one. There is a Australasian one down there near Australia. You can see it's mainly a year-round resident. And the Caribbean subspecies over here that we have that's a paler. They all are very similar, and they just have some markings, the coloration, the plumage, and somewhat size there in the variation. Well, ospreys, are amazingly well adapted to fishing for catching fish. Their long legs, for example, allow them to penetrate sometimes as deep as a meter below the surface to grab these fish. They weigh about 3.5 pounds for a male, about 4.5 to 5 for a female. So the females are roughly about 35% bigger than the males. They can live upwards of 8 to 10 years on average, but the lifespan has been gone as long as 32 years worldwide. I think in North America it's around 28 years, but in Europe I think there was one that once lived at 32. You can see the osprey's diet consists of a wide variety of fish. It really adapts to what it has most abundant and easiest to catch. Though in the Chesapeake Bay, the Atlantic Menhaden is a very high energy oily fish that you see as a primary food source, especially in the saltier parts of the bay. Here at Jug Bay, where I am, where it's essentially fresh water, usually 0.1 part per 1,000, not even a tenth of a part per 1,000. It's generally not on their diet, their menu is very irregular. You see gizzard shad is probably one of our main items here. The catfish is very common, multiple species from the blue catfish, channel catfish, bullheads, perch are common here. And as you get downriver, you start to see sometimes sea trout, but they're very opportunistic and they will take, as you can see, mullet, bullhead, and sunfish. Here at Jug Bay, you can see the gizzard shad in the top right corner, but look at the goldfish. And these are all different examples of goldfish that I'm seeing here. The goldfish has become probably at least 30% of their diet here at Jug Bay, which is highly unusual. People let these goldfish go in the river years ago, and now they've become a staple, though they're not nearly as nutritious as a menhaden or gizzard shad. Their makeup is not anywhere near in terms of the nutritional density that the menhaden do because of the oily flesh they have from eating the zoo and phytoplankton. But some of these goldfish are up to 14 inches long, weighing up to 2 pounds. Here again, you can see the osprey's eye locked on the target as it's coming in. It has very high density photoreceptors in there that are amazing that this bird can see things at least anywhere. The estimates are 3 to 19 times higher than what humans can see. They can see UV light. They even have the dark eye bands you see around the eye that absorb light, kind of like a football player does with eye black to prevent the glare. There's tiny oil droplets in their eye cells, in the rods and cones that act as a polarizing filter to help prevent them from getting a lot of glare in their eye when they see a fish, which they can actually judge for their the parallax effect below the refractive index below the surface. They have nictitating membrane, as you can see on the right picture over here. I'm pointing at the membrane is actually covering the eye that protects it as they enter the water. This sequence shows you how they fold their wings back to protect themselves as they dive down, sometimes from height as high as 150 feet in the air. Generally, they're hunting under 100, but they can go quite high and generally successful in about every one out of every 3 or 4 attempts. They need about 300 grams a day of fish roughly to support one osprey. Their talons, as you can see, are extremely well adapted. They're about 1.5 inches to almost 2 inches long. Some of them, they have what's called facultative zygodactyly, and that's a reversible talon. This outer one here can swing around to the back to give them 2 opposing 2 in the front with 2 in the back, and the bottom of their foot is covered with spines called spicules. This is a juvenile one I'm pointing out on the left, and you can see even at 5 weeks, the feet are pretty much fully grown. The talons will continue to grow, but they need that as their method to hold on to the fish and to tear them apart. So their feet are probably the fastest developing part, the feet and legs. On the right is an adult, much older. You can see the feet have been stained with blood and algae and whatnot, but the legs are very long and thin with very light feathering on them to not absorb any water as the least amount as possible. They have a uropygial gland at the base of their tail, which allows them to remain completely waterproof, at least for a period of time. The more they dive in, the more they have to re-up the oil throughout their feathers by the uropygial glands on the back at the base of the tail, and they squeeze out. When you see them, they often they'll squeeze it with their beak and preen it throughout their feathers. This bird, as a matter of fact, is a female. You can see the dark brown necklace or markings just below the head that indicate that. The nostril on an osprey, you can see right here, it has 2 openings split by a small fleshy post, but the skin above it has a flap to it that they can close this, unlike other birds of prey, to seal water out on impact. They have a longer than normal intestine that also allows them to digest almost everything a fish has. The skulls of catfish are about the only thing that I see that they can't crush because their beak, as powerful it is, can't get through the thick bone, and gill operculums from fish often are left behind. So, as I said, the average life was about 8 to 10 years. They have a highly flexible outer wrist joint that allows them to hover in place when they're fishing and keeping their head still so they can focus on the water. You can see they're very long, thin wings compared to a lot of other raptors. They also are named for that V-22 osprey because of its ability to fly and hover like an osprey. Here you can see a very distinctive difference between the male on the left and the female on the right. The female is much bigger in this case. It's partly the angle, and she's fluffed up, but the weight, like I said, is generally at least 1 pound more than the male itself is. Now, this advantage to this evolutionary is the male does the fishing. So a male that weighs 30% less eats 30% less. So his food is passed on to her and the young. So here's another view of one pair sitting over a group of small little blue herons that were migrating through. The ospreys had just returned. The male's on the left, the female's a little bit chunkier, you can see on the right, and larger than him. But obviously the little blue herons, the juveniles there, don't recognize them as a threat because this, you would never see that with an eagle anywhere nearby. Osprey nest towers have really been one of the secrets to helping ospreys recover from the DDT era. They've adapted to the point where these towers we put up using kids, volunteers, and others. You can see, as my survey shows, that of all these nests, the vast majority on man-made structures directly for them. Trees are almost insignificant now in the Chesapeake Bay. Channel markers, you see percentage duck blinds and other. Some of the unusual things: on top of someone's jet ski, they built a nest. On top of this guy's boat over here on the lift, channel marker, and even this was the old Potomac River Bridge. So here I've kept records for over 40 years of all the ospreys returns. It's generally slowly going down from around St. Patrick's Day. It's getting around to sometimes in mid-February, mid to late February now with the climate change issues. They first get here, they begin building the nest immediately. The male reclaims the site. They arrive first, and then the females come in, usually sometimes within the same day, within hours of the male, but usually within a couple of days. the male reclaims. So the same pair will breed for life and as long as each one lives. The female begins incubation, which lasts about 35 days or so, give or take a few days. The male will incubate maybe maybe a quarter of the time, 15–20%. The eggs, generally, they lay 3 eggs. You can see what they look like. They're about the size of a large chicken egg. This nest has in it, you can see American flags and a part of a spine that was butchered of a deer. You never know what they're going to bring in. You can see the chicks when they hatch after those about 5 weeks. You can see the 3 typically start, but often whittles down to 2 or 1 after that. The chicks in 2 weeks, you can see how much they've grown in 2 to 2.5 weeks. They incredible growth rate when they're the high demand for fish being brought in at that time. Here's a nest with 4 chicks, something I don't see anymore, but you can see the staggered ages of them. It's an asymmetric brood. Dr. Brian Watts likes to talk about this a lot because you can see the size difference is obvious between the one on the right and the left. The first one hatched because the hatching is asynchronous. They lay the first egg and begin incubation. The other ones have a disadvantage. And if the food delivery is behind, that's what happens. You'll see the one bird gets ahead and develop a dominance hierarchy. Here at about 5 weeks, these two are pretty symmetrical. At 5 weeks, they're fully feathered. And they hide like this, laying still in the nest. At about 8 weeks, 7 weeks or so, they're getting ready to fly. By between the 7th and 8th week, they usually begin to take flight. They're exercising their wings here. At that point, you can see the adult on the right versus the juvenile on the left, the yellow eye of an adult compared to the orange eye. That will change while they spend the first 2 years of their life down in South America. Again, you can see that dark eye band that cuts the glare down. Some of the things that have hurt ospreys, obviously DDT spraying, like this picture on the left. You see people in suits and hats spraying DDT that they thought was safe back then into the marsh. Bald eagles have really made a massive increase here in recent times to also potentially impacting them here. We're seeing that here, eagles even taking the young and eating them and also harassing ospreys through kleptoparasitism. You see raccoons are a big factor, especially in any tree nest. All of my 72 nest platforms I have in the Jug Bay area all have predator guards to keep raccoons out. Even on a low tide, they could swim or they walk out on the mud and get to the wooden towers. So especially these tree nests. And a great horned owl takes a high percentage of chicks every year. I would estimate 10 to 15% of ours are preyed on by great horned owl. Fishing line, another big factor. Here you see a chick hanging from the nest that's mummified now, but it's tied in fishing line. It fell over the side and was hung. There you can see I've come across this every year in nests when we're banding and tagging the birds. You can see that the leg is almost cut off and being severed, but fortunately that one we got off in time. You can see material like that purple netting material from vegetable bags can also cause it. Here you see an osprey with an adult. This was at a Hog Island nest in Maine, just to show you how an osprey cannot defend off usually as the eagle takes a chick right out of the nest. One jumped out prematurely but made it to safety. So this is just to give you an idea of how quick it can happen. So let me see. Let me go on here. Might have to play
Greg,
it out.
do you want to focus a little bit on what you're seeing, current population trends and some of the productivity challenges before we switch over to dig into Menhaden?
Yeah. Here, so I'm looking right now at this is influence. Another thing, weather has a massive influence. We've had a La Nina conditions for 4 straight years. You can see as the rain goes up, osprey production goes down. This is looking back for the past 20 some years. These are some of my band recoveries. You can see where they are in the U.S. and how they end up down there. All right. Now, the Menhaden is one of the fish that is considered one of the top and most important ones on the osprey's menu, especially in the salty and brackish areas. The Menhaden is a filter feeder. It's known, as you can see, as the monowatiog. It means fertilizer in Algonquin, called bunker or pogies. You see one carrying one right here. Here you see some of the benefits of it, the energy density, high oil content, making the dense source of calories available to ospreys, rich in omega-3s because of them eating all this plankton. You can see essential for reproduction. If they're not in really high quality physiological physiological condition, they probably won't be able to produce eggs or get through the nesting season. It's non-replaceable. The main stem menhaden appear to be a non-replaceable component of the osprey diet, showing their super nutritional value compared to other fish. If you ever get a chance, watch this film, The Biggest Little Fish You've Never Seen. We'll tell you more about the menhaden industry and their value to humans and what they're used for. We started a survey this past 2 years with Brian Watts, who's in the center there in the tan right in front of the engine, and his grad student, Michael Academia, was here in the front. I'm in the back. We surveyed the Patuxent River circled. You can see the freshwater section in the blue. All of the blue areas are the low salinity, and the red are the higher salinity sections around the bay. These are some of the data contributors here, and this was combined by Brian Watts. Productivity, you can see what it is. You want to generally have about 1.1 chicks per pair produced. This year, when we did it, we normally would cover 56 to 57 miles in 7 to 8 hours looking at the river. This year, we had to go over 76 miles to get just a barely good sample because there were so few ospreys nesting. Here's in the Patuxent River, you can see it's broken. We broke it down into 3 main salinity areas: freshwater at Jug Bay, Benedict in the middle, lower part, Brooms and Solomons. So you can see in that lower area, we've only found 14 total nests. Only 7 pairs produced 14 chicks. You see the normal is 150 to 180 pairs in that segment, so less than 10% normal breeding. The Benedict section was a little better, that where menhaden is still on the diet is important. Only 18 pairs compared to normally 90 to 100, so less than 20% of the normal breeding population. And you see 11S, 29 total pairs, and 28 pairs. Jug Bay, the freshwater portion, produced 44 chicks, more than the entire 2 lower sections of the river combined, where there's generally over 300 nest sites. So our 70, which only 28 produced, which is low in itself, you can see that it accounted for more than half the population, which is highly unusual. In 2024, you see the reproductive rate dropped to less than 0.6 chicks per active nest in the main stem of the Chesapeake Bay. This is under what Brian found. Osprey, which nest in the main stem of the Chesapeake Bay, are no longer sustainable. At the minimum rate needs to be 1.15 per nest or greater. And you can see a dead chick in the nest. These osprey breeding outcomes you can see here for 2024. The main thing to look at in the right column, 0.51 reproductive rate in all the high salinity areas. In the freshwater low salinity areas, 1.31 chicks per nest. You can see that big difference, massive difference. So the average was double the productivity of chicks per nest compared to the higher salinity areas.
And Greg, we'll take another minute just to wrap up, and then we'll dig into Menhaden before the Q&A.
Yeah, I'm getting toward the end here. And so you can see the freshwater area, the trend has been, the Jug Bay is the fresh, the orange and the yellow are the areas of Benedict to Brooms, and you can see how the chicks per nest production are dropping dramatically. And in 2025, here is the main results. The high salinity only produced 0.25 young per pair, moderate salinity 0.31, and then the low salinity over 1. So you can see the main finding is that the reproductive deficit is not restricted to 10 parts per thousand salinity, but to tributaries up to 5 parts per thousand. This contour includes more than 80% of the surface waters of the Chesapeake. And just showing you some of my nest areas here, this year we only had a total of 79 nest attempts compared to over 286 in 2024. So it's dropped dramatically by almost 3/4. And you can see that only 95 chicks were produced this year compared to a good year in 2019, the last really excellent year, and 2022, over 400. I saw this a lot. The ospreys sitting on that had adults that had just hung out. They normally don't do this. They had abandoned all their nests, and I saw 11 right in this one location, all sitting here. There are dolphins we saw in large numbers. More than 100 dolphins were coming up the Patuxent in areas they're never seen. Here they are, dolphins going after school in Menhaden. This is highly unusual. We feel like they're looking for the fish, and we think that's why they failed. And in concluding here, just saying that another A bird that has suffered a major decline was the common mule in Alaska. You can see dead ones on the beach, and the colony before and after this major collapse. I really have a belief, and a lot of people do, that climate change is dramatically affecting fish populations. So the warmer conditions which we're having right now, and this is literally a month ago, the Pacific is at another super high temperature, and these ecosystem changes, they believe, becoming more frequent, and the ecosystem may no longer support this. So what this is getting at is, if Menhaden are being affected by it, the crash of their population, could this be happening, something similar to what happened as an analogy of what's in Alaska? But you can see the Osprey Menhaden story. To me, this was a good quote, illustrates a scientific principle that everything is connected to everything else, the first law of ecology, and therefore single species management is ill-advised. You have to manage the population for not only these beautiful ospreys, and to see, what are the anthropogenic reasons for osprey to be declining? How are we influencing the environment? And if we don't, we may not be able to stabilize the population. In some areas, they'll continue on, but we may have seen the peak of osprey in the bay. Roger Tory Peterson once said, birds are the sensitive indicator of the environment, a sort of ecological litmus paper. The observation, recording of bird populations over time lead inevitably to environmental awareness and can signal the impending changes. And I think that is perfect. So thank you. I'll get off the screen and transfer over to Will.
Thanks, Greg.
Okay.
And Will, feel free to take it away.
Yep, I'm sliding on right now. Thank you, Melissa. Thank you, Greg. And thanks to the Chesapeake Research Consortium for putting this together and talking about such an important subject here in the Chesapeake Bay and broader throughout the Atlantic coast ecosystem. So my name is Will Poston. I'm the Forage Campaign Manager here at the Chesapeake Bay Foundation. Pretty much exclusively working on Atlantic Menhaden these days. CBF has worked on Menhaden for decades, which really recognizes the value that Menhaden provide here in the Chesapeake Bay for our ecosystem, for our coastal communities, and for productive fisheries. All right, next slide. So as way of background here, Menhaden are a small, nutrient-dense fish found from Florida to Canada. Greg mentioned just how nutritious they are and how their caloric density and their fat content is so critical to both osprey, but also for other species, striped bass, redfish, bluefish, bluefin tuna, marine mammals such as humpback whales and bottlenose dolphin are all shown to be very reliant on Atlantic Menhaden. And something we'll touch on later in the management context, in the science context, is striped bass are determined to be one of the most sensitive species to Menhaden abundance, which has important implications as well. Menhaden are one of the most important forage fisheries, both here in the Chesapeake Bay and throughout the coast, because of the critical link that they provide in marine food webs. As filter feeders, Menhaden very efficiently and effectively transfer nutrients pretty much directly from the sun's solar energy that develops nutrients through photosynthesis and phytoplankton, all the way up to those top predators that I mentioned and that are on the left side of the screen here. Menhaden are small. The maximum size you'll generally see is about 12 inches, but as peanut bunker, the smaller, juvenile Menhaden, that's one of the primary food sources for many of our fish species. Menhaden will spawn in the offshore continental shelf, so way, way out in the ocean. And then the larvae, the little Menhaden babies in their egg sacs will drift into estuaries on tidal currents and winds. And historically, the Chesapeake Bay has been one of the largest nurseries for Menhaden. So I'll just kind of breeze over this because Greg touched on it so extensively, but Osprey and Menhaden are inextricably connected, particularly in the lower in the bay down here in Virginia, in the main stem of the bay, and generally in the saltier portions of the Chesapeake Bay. In those portions, historic monitoring and scientific research efforts have shown Menhaden to make up a significant portion of Osprey diet. And what we've seen with Osprey is a declining productivity rate. They're not raising enough chicks, and that's largely due to lack of available food. And as I mentioned, in many of these portions of the bay, where Osprey had traditionally been more reliant on Atlantic menhaden, those chicks are surviving at a rate, even worse than during the DDT crisis. And, the science is pointing to food stress, and that is evidenced by, as Greg mentioned, increased foraging time, asymmetric broods, et cetera. And what's important to note with Menhaden is, Menhaden they're a schooling fish. So, they provide both an easy target for Osprey when they're abundant because they're very visible and Osprey will swoop down and grab them easily. But they're also far more nutritious than other fish species. And that caloric value is especially critical during the breeding and nesting periods where the caloric demand is highest. So some quick background on how Menhaden are managed. Um, Historically, Menhaden has been the largest fishery on the Atlantic coast by weight. This that should alarm some people because this is it's such a valuable forage fish. Now, that fact is largely driven by what's called the reduction fishery, and that's what we have here in the Chesapeake Bay. Um, Historically, reduction plants, which is the process of scooping up large volumes of menhaden, bringing them back to a factory, and then grinding and cooking them down for industrial products such as fish meal and fish oil. Today, the sole remaining reduction fishery is based here in Virginia, up in the northern neck region of Reedville. Um, so that is the largest contributor to Atlantic menhaden commercial removals. Today, menhaden are managed primarily by the Atlantic States Marine Fisheries Commission, which is an interstate body that manages our, inshore and nearshore fisheries up and down the Atlantic coast. And, menhaden management is relatively new. Catch limits are explicit catch limits with menhaden are really a factor of the 21st century. Prior to that, there was very little formal management. And in that short time period of formally managing this forage fish, we have made some pretty significant and transformational changes. Notably, since 2020, Atlantic menhaden have been managed through what's called the ecological reference point process. And this explicitly, it's a stock assessment process that's, it's one of the most advanced fisheries science and assessment processes that we have. And it explicitly accounts for the role that menhaden play in the ecosystem. So, as way of example, the way we are currently using ERP management is to ensure that there are enough menhaden in the water to support a fully rebuilt striped bass stock. And that is believed to provide enough forage for the other focal species like, our bluefish, osprey, tuna, just the broader ecosystem. And in addition to working on the stock assessments and setting coast-wide catch limits, the ASMFC will also allocate fishing quota amongst the various states. They take part in data collection, and there's also an enforcement angle to ASMFC. So just to kind of talk about, the volume that we're working with these days. In 2025, Virginia has a Menhaden quota of 383 million pounds. That's about 75% of the coastwide harvest limits. Now, compared to their northern neighbors in the Chesapeake Bay, Maryland and PRFC, the Potomac River Fisheries Commission, their quota is just 11.5 million pounds. So there's long been this discrepancy in the bay where the fishery is very much concentrated in Virginia's waters, and that's been largely a factor of historical landings. Where the reduction fishery really concentrated in Virginia up and down the coast, and then that translates into today's allocation scheme. In addition, the Chesapeake Bay has a precautionary catch cap for the reduction fishery. And today that catch cap is 51,000 metric tons or 112 million pounds. Now, so that means that the reduction fishery, which again, there's only, it's a single entity. It's the last remaining operation on the coast, but they are limited to 112 million pounds of Atlantic Menhaden in Chesapeake Bay waters west of the Chesapeake Bay Bridge Tunnel. And it's important to note that cap, that harvest limit, is not based in science, but again, based on historical landings. And I'll touch on this a little bit more in the next slide. But Menhaden science has been, the Virginia Institute of Marine Science called the state of Chesapeake Bay Menhaden science woefully inadequate. We consistently do not have, the ideal levels of science and data to inform sustainable Chesapeake Bay ecosystem-based management. So as I mentioned, the Atlantic States Marine Fisheries Commission regularly conducts stock assessments on Menhaden, and one of those stock assessments considers the broader ecosystem throughout the Atlantic coast. Now, just last week, a peer-reviewed version of the 2025 stock assessments was released, and that is going to be critical to inform future management. And I won't go too much into the weeds, but as these processes are incredibly complex, but there were some notable changes from this stock assessment versus the previous one several years back. Notably, the natural mortality estimate, which is the amount of Menhaden that the scientists assume die in the ecosystem, that estimate changed in this new stock assessment, and it was lowered based on some new analysis of older data sets. And what that resulted in is it scaled down the total biomass estimate. So, in 2022, we thought the stock was, I'm just speaking in hypothetical numbers here, but we thought the stock was a 10. In 2025, now we think the stock size is around a 6.5. So it scaled down the size of the population. And that has the impact of dramatically changing the level of harvest that managers will be considering as they set new catch limits moving forward. So that's important to note. And then this chart on the left, it's somewhat confusing, but this is kind of the trade-off that managers consider. As I mentioned, the ecological reference point for Menhaden is, they want to leave enough Menhaden in the water to support a striped bass a striped bass population that is at the striped bass target. So as you can see, as you increase fishing mortality on Atlantic menhaden, striped bass population, the ratio compared to their target declines with it. Um, so that's again to say that striped bass are, a sensitive species to menhaden, and menhaden sustainable menhaden conservation is a piece of striped bass management as well. This chart in the middle just kind of shows how complex these stock assessments are. There are countless data sets factored in, and again, it the intent is to try to effectively capture what the ecosystem is doing, what the ecosystem needs in its forage availability, and how fishery managers can develop management strategies to balance and to have a balanced ecosystem. Now, just of note, in a couple weeks, the Atlantic States Marine Fisheries Commission will be reviewing the results of these stock assessments um, and deciding new catch limits. So that will be a very pivotal meeting for both menhaden management and the fate of some of our Chesapeake Bay issues as we're talking about osprey and some of the other species. So I know we're kind of running a little late. So Melissa.
No worries. Thank you so much. It's a challenging topic to boil down into 12-minute talks, and we really appreciate both Greg and Will for trying to give us that context. Folks online, if you have questions, feel free to drop them in the chat. I do have a couple of questions to kick things off from some that were submitted ahead of time. And, Will, you touched on the management considerations that fisheries managers are wrestling with as they create their management plans. Is there any sort of requirement or effort to consider impacts on osprey as they're making those decisions? And I'll send this to Will first, and then Greg, if you have any thoughts, feel free to add in.
So I'll couch my response in a couple different ways. Osprey are now formally considered in the ecological reference point stock assessment process. And that model identifies osprey as a very sensitive species to menhaden abundance. Now, on the flip side, that process has also found that, osprey are likely not having enough of an impact to change menhaden abundance. But again, they're important. And on the Chesapeake Bay management side, the concerns about osprey productivity has fueled management discussions at the ASMFC. Last August in 2024, a work group was stood up to explore these problems and challenges that we're seeing with osprey and consider how management change might provide some relief to osprey. And back in a couple months ago, the same that same group at the ASMFC formally made a motion to develop management options to consider quota periods within the Chesapeake Bay to try to distribute reduction fishing effort throughout the year as a way to leave more menhaden in the water when they're needed. And finally, I'll mention with this new stock assessment and potentially major catch reductions coming, the osprey challenge will likely be a point of contention towards achieving commensurate reductions to the bay cap as a result of the coast-wide reductions.
Great, thank you, Will. Greg, I don't know if you had anything you wanted to add to that.
Well, one thing I thought he covered it really well, what he had to say. Even if they started today to regulate tighter the menhaden fishing, you don't know what the long-term the damage may have already been done in many ways, and that's what we're seeing. Things, unusual behaviors, and things that maybe might take years for them to catch back up. From what the decline we've seen this year, I think it would not be changed because so many pairs vanished. We don't know where they went. It doesn't appear they survived or made it back here. And so even if you curtail the fishing in certain areas, the whole bay, the whole ecosystem has been affected by it, and it could be a long-term thing like it was with the common mewers. It may not, come back to where it was. We may have passed the maximum capacity for osprey.
Great, thank you. And can you reiterate, Will, again, when the decision will come from the ASMFC?
Yeah, yes, and it's a fun abbreviation, but October 28th, the Atlantic States Marine Fisheries Commission will be meeting. It's actually in Dewey, Delaware, but there are online viewing opportunities. If people are interested in learning more, the meeting materials will be posted shortly, and you can even email public comments up until next Tuesday.
Great, thanks. And Will, we can share some of that information in our follow-up email if folks are interested in learning more. That's something we could include.
Great.
There's a question in the chat asking if there's any sort of lobbying group that's representing Menhaden fishing, and if so, how has their activity influenced any sort of regulations or legislation?
Yeah, I can handle that. Here in Virginia, like I mentioned, Virginia hosts the sole remaining reduction fishery on the Atlantic coast. That is ocean harvesters, which are the formal fishing boats, and Omega Protein, which is the processing plant. Omega Protein is currently owned by Cook Aquaculture, which is a giant multinational aquaculture company that's based in Canada. And in regard to the direct political influence, Omega Protein and Ocean Harvesters have not, their political influence is not hidden. You can go up on the Virginia Public Access Project and see how much both of these entities are contributing to political campaigns, spending on lobbyists, and it was really exemplified this past winter in the Virginia General Assembly. CBF and many of our other partners, local and national, worked to fund and initiate that sorely needed Chesapeake Bay Menhaden science that I referenced earlier. It was in the state budget up until the final day, and in-person negotiations with my colleagues, budget or Virginia legislators and representatives of the industry, ultimately the industry's influence was able to remove the funding for that science out of the state budget. And we continue to find ourselves for the third year in a row with a science plan that is, stuck on someone's desk, and we're not getting these answers amid, continued and intensifying warning signs, as Greg noted with the Osprey Productivity Challenge, and even local watermen here in the Chesapeake Bay that catch menhaden at a far lesser scale. They're seeing their catch rates decline dramatically as well.
Thanks, Will. Greg, when we were advertising for this webinar, we got a lot of comments and observations from some of our participants noting how they have seen osprey populations change over time. Some stating that they've seen just locally declined numbers. Others are stating that their local populations seem to still be thriving. Is there any sort of pattern to where we're seeing some of the population impacts, or is it more sporadic across the bay?
Yes, the higher salinity areas, as I had that one of those tables showed, it's they are suffering the most, and those are the areas where menhaden is probably between 70 and 80% of the diet of the osprey. Here, they're feeding on so many different species, they make up the deficit. But in those areas, that the Menhaden is just, it's easy for them to catch. It's in large schools normally. We see a lot of them with small ones. A lot of the smaller Menhaden they call peanut bunker have come in, but it's kind of like somebody eating junk food for them. It doesn't have the same nutritional density that the larger Menhaden, which seem to be lacking. But yeah, so if you see osprey in your area and say the salinity's lower, that could be the reason, because here at Jug Bay, that's exactly, you saw the production just in our 28 towers produce more than the lower 220, 230 combined, or actually closer to 300 nests. So many pairs have disappeared. So I think locally people will see some little upticks, but the majority of the people I encountered said their ospreys either didn't come back, they just hung around the nest, they didn't go through the motions, they were running in general weeks behind, 2 to 3 or more weeks behind this year. I also think that has to do with climate issues and this La Nina condition we've had for 4 straight years.
Great, thank you. And another question that came in ahead of time was really talking about some of the human uses for Menhaden, the oil and the fish meal that are driving some of the fishing pressure, and asking if there are alternatives to that either could be explored or have been explored in the past.
Yeah, it's a great question, and it's one that we really lack hard, updated information on, and that's because years ago, or not years ago, back in 2017, when Omega Protein was purchased by Cook Aquaculture, it went from a publicly traded company where you could understand those market or business dynamics publicly to a privately traded company. So we don't have very good understanding for exactly where Chesapeake Bay Menhaden is going in the industrial sense. But broadly speaking, reduction caught Menhaden are being converted to fish meal and fish oil. Now, that has both, aquaculture feed sources, livestock feed, pet food, and then there's a human aspect too for, omega-3 fish pills, as an example, or cosmetic products. Believe it or not, omega or Menhaden oil is used in makeup and other cosmetics. So it's kind of spread all throughout. There's some novel work going to try to explore other aquaculture feed sources that are more sustainable and not removing a wild forage fish from marine ecosystems. But those are not anywhere near the scale that these aquaculture operations throughout the globe require.
Great. Thanks, Will. And another question about sort of the correlation between the declines that we're seeing in Menhaden and Osprey. Have there been other points in history prior to this where we've seen a similar decline? And I'm wondering, if so, what the driver behind that decline might be.
For Osprey or Menhaden?
Both. I think the question was about, have we seen a dual decline in the past?
Well, as far as ospreys, it would be hard to quantify. I can say that I've seen that in the late 1800s, and Will could attest to this, that Menhaden suffered a major crash because of overfishing. And then again in the 1950s, they were really in serious trouble, the Menhaden population, again from the overfishing industry. And I'm sure, but no, I've never seen documentation of what were ospreys doing at that point. That's a good question. There may not be good evidence or enough research available to say, hey, they were crashing alongside of it. But of course, the numbers they caught in the 50s were many times what they caught what they're catching now, the population just is not as sustainable. I think. Would you agree with that, Will, as it was once?
I think that's one way to put it and probably capturing it correctly. While there was far greater reduction fishing effort and pressure in the earlier part of this time series in the 50s through the mid 20th century, and like you said, a lot of those reduction fishing plants and operations that were all the way up in New England and Long Island Sound, those plants had closed for a variety of reasons, but one being overfishing and lack of available fish. I think today we find ourselves in a bit of a different situation with changing climate conditions. That's just another layer of stress that we're placing on these fisheries. So, I have a tough time in this day and age, like looking back at those times in the 60s where there were no Menhaden regulations, catch limits were not informed by ecological reference points and science. It's not an apples to apples comparison. And, what we're seeing now is, what might have been sustainable even 10 years ago is showing extreme signs of stress here in the Chesapeake Bay that, warrants additional precautionary management, because we don't have all the information and because there are so many other changes, happening within our ecosystem.
Great, thank you. Time for one last question. And the question that I have here is wondering about other impacts to the Menhaden population, other species like blue catfish or anything else that might be influencing the decline other than the fishing pressure.
I would like to say a quick thing and then see what Will has to say. Here on the Patuxents, a lot of the DNR fisheries people have told me they've done estimates, surveys where they think there's at least more than 100,000 of blue catfish alone just within around Jug Bay, within a mile or couple miles of the heart of it. So some of these blue cats, which didn't exist years ago, are eating a lot of the forage fish that ospreys prey on. I've seen some of these blue cats as big as 95 pounds caught out here. 20-year-old fish that eat everything in sight, and we've done food habits looking at their stomachs. So yes, they could be impacting osprey because they're eating the bigger ones, especially eating some of their main prey items. Add in cormorant population has increased dramatically. The bald eagle has exploded here. They used to be rare. Now they're everywhere now. They're actually causing ospreys, I've noticed, to abandon their nest sites. So yeah, the blue cat, I think, definitely is a underlooked how much it could be having impact on ospreys and other fish species just because of they're such a predatory fish. What do you have to say, Will? What do you think?
Yeah, I think it's undeniably blue catfish are expanding throughout the Chesapeake Bay watershed at unfathomable rates. Some of the diet studies that I've seen that have come out in the past few years, you're seeing more like gizzard shad and perch, which are further up the tributaries, right? And much like the osprey diet, Menhaden make up a greater percentage in the saltier portions, and that's not to say blue catfish aren't in the saltier portions, but I think they're having an impact on the ecosystem. I'm not entirely convinced that they are a driving factor in what we're seeing with Menhaden. But I'd love to see some additional science done here in the Chesapeake Bay to address that issue.
I will say one thing. We opened up one 39-inch blue cat, and inside were a 13-inch shad and a 8-inch perch in the stomach, which are right in the wheelhouse of osprey in terms of size. This was just one cat, and you see lots of, and they radio tracked some of them, and they went down the Patuxent from here at the freshwater all the way to the bay and up to Chesapeake Beach. They traveled more than 70 miles, some of them, to get to that location. So they are very tolerant of the wide-ranging salinities of the Chesapeake Bay, especially when you have freshwater events decreasing the salinity. So they've been much more of a problem than anybody ever anticipated. So yeah, that's a tough thing to study, but you're right. I feel like it's something that should be looked at closer, because I think we're hitting a perfect storm of many factors. The Menhaden, possibly the overfishing of them. You're having blue cats in here, bald eagles, weather conditions, climate change, like I mentioned earlier. All of that coming together at a bad time and causing this perfect storm of decline of the Osprey.
Yeah, and Melissa, if I could just really quickly add on to Greg's point, there are so many factors impacting our Osprey, our Menhaden, our broader Chesapeake Bay ecosystem. Unfortunately, we as advocates and stakeholders and professionals, don't necessarily have the magic wand to improve Chesapeake Bay water quality overnight, improve or cancel out climate change. The only things that we really can control right now are, fishing mortality rates of Menhaden to try to relieve stress on this struggling ecosystem and, these struggling warning signs that we're seeing out of Osprey. So I think that's an important kind of aspect to capture and maybe end on.
Great. Thank you so much. And thank you, Greg and Will. This is a huge topic that we have asked you to probably unfairly boil down in a 1 hour conversation, but you did such a great job. And we know we have questions that we weren't able to address. We will send them to the speakers for any thoughts that they might have and share them along with some additional resources to you in our follow-up email. You see the link to the survey on the screen. As always, we would value your feedback, and we look forward to seeing you for our next roundtable conversation on November 19th. So thank you again to our speakers and all of our participants today.
Thank you for having us.
Thank you.
Thanks, everyone.